So thank you for the opportunity to come in and talk to you. I'm going to tell you briefly why I'm interested in plastic ocean waste. There's a much longer presentation that's available on the web that talks about some of the motivations and the issues. What I'm going to focus on is where the project is now, and in those next steps, how Sustainable Seward, I'm hoping, will be a component for our success, and the city of Seward in general, and then open to Q&A. So with that, plastic ocean waste, the problem is, and that right now they're saying it's 11 million metric tons of plastic is leaking into the ocean each year. That was first publicized quite well by an article in Science by Jenna Jambeck and her colleagues, and then repeated by the MacArthur Foundation. And then the MacArthur Foundation had said this is equivalent to uploading or dumping one garbage truck every minute into the ocean. So everybody can kind of visualize a garbage truck backing up and boop, there's a garbage truck a minute going in. The bad news is by 2030, this will probably double, and we're on track for that. As you see, it's 2022, and they're saying it's now 11 million metric tons. And by 2050, that number will quadruple. And in 2050, if that number does quadruple, there will be more mass, more weight in plastic in the ocean than there will be aquatic life. So that's a pretty daunting number, and it's definitely a problem. My specific interest right now is shoreline accumulation, and shoreline accumulation in Alaska in particular. The longer the plastic is on the beach, the further it degrades. And this is a National Park Service cleanup that was done in 2015. And one of the things you'll notice is that in addition to the fact that most of what we're seeing is plastic, this plastic is breaking up on the beach. Right here you see this could be a combination of high tides and high wind events, or it could be animals, which are also one of the reasons these plastics turn into microplastics. They get into smaller and smaller pieces. Polystyrene or styrofoam, this is everywhere on the beaches, and it breaks up very easily. And it's also one of the favorites for bears to play with. So apparently they get their hands on this and they break it into these little beads. So you're seeing fish nets, cans and jugs, polystyrene, PVC buoys, other things, metal, for example, and then bottles. The problem is that these particles, these plastics, when they get on the beach in these high tide, high wind events, are breaking into smaller and smaller particles. And those microplastics are now leaching their way into our food supply. And so we need to get them before they get to that point. And let me give you kind of a real pointed example of that here in Alaska. Just to finish this picture, the National Park Service went through and cataloged what they found in 2015, and they found that 88% of what they were collecting was plastic. So the majority of the marine debris that's coming onto the beach is plastic. Now, there's other things that probably sink and are not making their way to shore. So what we're looking at is things that are buoyant. Now, I went out on a shoreline cleanup with the Prince William Sound Stewardship Foundation last summer. We covered about 8 beaches on Knight Island in the Prince William Sound. And just before I went out in June, I had read an article that these Australians had said, hey, I think 99% of the plastic that comes on shore stays on shore. So up till that point, there was a lot of conjecture, I would say, that the plastic is kind of moving in and out of the shore. So at high tide events, it comes off, and then it maybe goes out and floats around a bit and then reaccumulates on other beaches, possibly sinks. Maybe it continues out further and gets stuck in one of the gyres. But this Australian article said, no, what's happening is in these high tide, high wind events, the plastic is getting thrown up into the vegetation above the high water line, and it's just staying there. It's getting recovered and recovered. And so we're just creating layer after layer after layer of this microplastic. So I just picked a random spot on Knight Island in a random bay, and I walked up and I just pulled back the vegetation. So this wasn't cherry picking at all. I just went up and pulled back the vegetation. And this is what I found. I'll zoom in on this. but you can clearly see the abundance of microplastics this is accumulating, and this is above the shoreline. So it's at a point here where I don't know how to clean this up easily. Even if you were to get there with tweezers and have somebody doing this, the amount of this up here is just overwhelming so quickly. And you can tell this is my boot right here. I'm a size 13, so it's not a small foot, but those are still small particles. So it's just emphasizing the problem. Some of the solutions that people are proposing, well, I think the ones that we really want is prevention. Let's just not let it get in the water. I'm 100% behind that. So how do we do that? Well, there's taxes, there's regulations, there's reuse, there's the elimination. There's all these different processes that are being put in place. The EU is probably taking the leadership role in this, if I have to be honest about where the governing bodies are doing the most progressive movements. And nonetheless, this is something that's very important. It's being done. Having said that, there's still a lot of plastic, 11 million metric tons a year, still getting into the water. And we need to do something with that. And that plastic is ending up in garbage patches and shallow coastal waters and beaches. And that cleanup in those areas is where I believe there's a gap. So the shallow water coastal beaches is the area specifically in Alaska that I'm focusing on. Now, when I first started looking at plastic ocean waste, I'm a question guy. I like to ask questions and then try to find the answers. This is maybe an engineering solution approach to life in general, but I looked at this and I said, okay, there's really three basic areas that I'm looking at this problem. One is assessment. Where is this plastic ocean waste? How much plastic ocean waste is there, and how fast does it accumulate? So that's really useful information, especially if you're trying to clean up specific beaches. You need to know when it gets there, how much there is, and where we should target our resources. Then in terms of collection, how can we reduce the collection costs? How can we take the cost per unit pound, which is what I think is kind of the standard way to evaluate this, and reduce that? Right now, we're spending between $1 and $6 a pound by the NOAA Marine Debris Clearinghouse's recollection. I went back 20 years and looked at all the data for Alaska, between $1 and $6 a pound to collect plastic or marine debris off of a beach. And then if we can reduce that cost, can we also increase the collection area? We are doing a good job cleaning up, but we tend to clean up the same beaches over and over and over again, because those are ones that we know how to get to, or they're easy enough to get to, or we've got history with them and we want to go back and clean them up because we know they reaccumulate quickly. But we need to broaden that. So there's a lot more beaches that we're not hitting. And then finally, utilization. How do we use that plastic ocean waste once it's collected? And can we do something useful with it locally? Sometimes you hear about people taking ocean waste and plastic waste, and they're doing something with it. What they're doing is they're turning it into beads and they're reselling it as bulk. I'm not thinking about this in terms of taking and converting it into a product that we ship out of state. I'm thinking about using it locally, where we convert that product into something we can use right there in the community in which it was collected. So here's a couple answers, or at least first cuts at answers. These are very, very rough approximations, but in terms of how much plastic ocean waste is on Alaska shores, somewhere between 77 and 104 million pounds is my guess. It's a guess. It's an educated guess. It's based on how much is going in the water, how much coastline we have, but it's a place to start. How much are we removing? Well, here's less of a guess, because we have the NOAA Marine Debris Clearinghouse. We know that at most, if every one of the Marine Debris Clearinghouse projects is working, we're collecting 377,000 pounds of marine debris. So of that, 66 to 99% is plastic, depending on who you talk to. But at most, we're getting 377,000 pounds off the beach each year. Well, that's 0.5 to 1% of 77 to 104 million. And let's say I'm off by a factor of 10, maybe it's 7 to 10 million. It's still a huge number, and we're not even close to getting there. So anyway, this is where I think we can spend a lot of effort and innovation to try to improve this part. So my vision is to find more affordable ways to remove this plastic ocean waste from the shorelines, convert that into useful products. I want to do this by flipping, what I call flipping the script. Instead of using a centralized processing facility, which is how almost everybody does this. They have a hub and spoke model where what they'll do is they'll take their centralized processor and they'll stick it in a very densely populated area, and then they'll truck in all of the plastic to that spot, convert it in that big facility, and then they ship out whatever the final product is. That doesn't work in remote places like Alaska. Our shipping costs will eat our lunch before we even get there. So what I'm thinking is, let's flip the script. Instead of doing this where there's a centralized facility, let's do distributed recycling. Let's actually take the recycling, make it mobile, and move that to the community, stockpile the plastic there, process it, and then move the processing system to the next facility. So I can move a container or 2 containers of processing equipment much more easily than I could moving several containers of plastic at much more low value. So that's the process. Then starting in Alaska and expanding. Oh, thank you. Okay.
Yeah.
Okay, thanks, Cody. Cody wanted me to tell you that I got mail. So thanks, Cody. Here's a couple ideas that I've been proposing. One is a compensated collection program. So I'm looking here now, I'm a fisherman's son, and I think, gosh, who knows this area, these beaches, better than those that are recreational fish or recreational boaters or commercial fishermen that are out in these areas all the time. So your recreational boaters, they go in these beaches, they see this. We have fishermen that fish next to these beaches. Why can't we use them as collection agents for us? Compensate them for that. So this is based on a model done by Plastic Bank and Clean Hub. Both of them are using this in a third world country, but they're working. I mean, this is actually a compensated collection program that works. So possibly that could be adapted here. I don't know, but I think it's at least worth considering. In terms of collection, I have this concept called the marine debris drone. There's these heavy lift drones now that can lift up to 1,000 pounds, and we can use those to actually go back and forth between the beach and the boat and pick up plastics or marine debris that's being collected. When I went out on that marine debris exercise last summer, I spent, I would say, more than half of my time taking a full bag of plastic and other waste and moving it from one spot to another. What I really think we want to do is we want to take the most valuable resource we have on that beach, which is a human, and keep them collecting, moving in as straight line as possible. And then as that bag is full, leave it behind and have a marine drone, these heavy lift drones come in and pick that bag up and take it back to the boat, and then bring out empty sacks when they're necessary, so that we can use these marine debris drones, if you will, these heavy lift drones, as kind of like garbage trucks. And then we're focusing our attention and our resources where we have the most value, which is the human. The thing I'm working on now that's funded is a mobile processing system. I have a concept that I've proposed to the U.S. Department of Agriculture through the Small Business Innovation Research Program. I have not heard yet if it's going to be funded, but the one that has been funded is through EPA, and that's to take number 2s, 4s, and 5s and convert those into recycled plastic lumber. I've got another concept that I'm working with Anchor and Sand and Gravel, where we would take the polystyrene and grind it up and use it as an aggregate for concrete. And that's just in its infancy, but there is some traction and some interest. So I'm hoping that that'll turn into something as well. But as you can see from this resin chart, you know, every one of these plastics is different. We can't take, or can't easily take PET, polyethylene terephthalate, and combine it with the high density polyethylene, because they have different melt points, they have different chemical compound mixtures. They're not compatible. So HDPE, polypropylene, and LDP, low density polyethylenes, those do kind of combine well. And we can use what's called a compatibilizer to kind of help that process. But it doesn't extend as well when we start looking at PET or polystyrene. This is an example of what that system would look like. This chart I put together when I was developing the proposal to EPA for Phase II. I had it as a 2-container system, where the first container would do sorting, grinding, cleaning, and drying. The big piece of equipment is the grinder. So this would have a grinder in it, and then there would be other components in there that would be done doing sorting, cleaning, and drying. A lot of that is manual. And then the second 40-foot container would house the extruder, which is this device here, which is the second large piece of equipment. And then it would take the plastic that's ground, cleaned, and dried, put it into this device here where it would, through an auger, heat it into a molten plastic and extrude it into these long tubes that are in the shape of a piece of plywood, or excuse me, it's a piece of lumber, not plywood. Plywood's harder to do. 2x2s, 2x4s, 4x4s, even fence posts that are round. And so then they would, once they were full, be detached, put over here in a cooling area, and another form would be attached and refilled. So a very manual process with the two key pieces of equipment being the grinder and the extruder. So I received a Phase II SBIR. So let me tell you briefly what that means. The Small Business Innovation Research Program is a $2.5 billion program that's housed within 11 of the agencies of the federal government: DOD, Department of Health and Human Services, EPA, USDA, NOAA. All of them have a portion of their budgets by law for small businesses to compete for innovative ideas to do a 3-phase program where they're taking some concept out to the point of commercialization. And hopefully that concept is addressing some specific need that they have within their agency, within their goals and strategic plan. So I applied to USDA, to NOAA, to Department of Energy, to the National Science Foundation, and to EPA. I wrote 8 different proposals in a year. This was during COVID. I figured, hey, I got PPP money. What am I going to do with it? Well, I sat down and I wrote a ton of proposals. And the EPA funded one. All the others, some of them were no thanks. Some of them were try again. USDA, for example, that I resubmitted and is still in consideration, was one of those. But the idea is that this is a program where I'm getting funded by the federal government to take and develop these concepts into working prototypes. So the first phase is feasibility. They give you a small amount of money. In this case, it was $100,000 from EPA. And then in the second phase, if you compete for each of these phases, if you're successful, then they give you $400,000 to do a pilot demonstration. That's where I'm at. I won the Phase I last March and was awarded a Phase II in January of this year. So it's a 2-year pilot program. In Phase I did the material testing. These are the different kinds of plastics coming off the beach. Completed these tests, demonstrated that this is adequate for recycled plastic lumber. And then as soon as I found out that I won the Phase I got plane tickets to go back to visit the vendor that's building the system for me. And this is the actual extruder and grinder that are going to be used. And as a part of that discussion, one of the things we realized was that we could put both of these in one 40-foot container. So now instead of those 2 that I had on that earlier diagram, we're down to 1. And then a lot of the other operations can be moved outside the 40-foot container. So this becomes even more mobile. I only have to take one 40-foot container and move it from community to community to do this job. These are some of the forms I was mentioning that you extrude the plastic into. And this is what the product looks like. This is actual recycled plastic lumber here, not from the beach. This was from residential streams, but it was recycled plastic lumber that was made into a 2x2. Here's a 2x6. Here's a fence post. They're even made into benches. So I'm going to do the pilot demonstration in South Central Alaska. I'm using in the first year the road system, and I'm going to work out of Seward, and then pulling in material from Homer's beach cleanup, potentially from Kenai. Also in Kenai, I'm working with a company called PESI, Petroleum Engineering Solutions. They have HDPE pipe thread protectors that I'm going to be able to get, which are going to be a great additive to the product. And so that is where I'm going to start. And then year 1, year 2, I'll be in Seward. In the second year, I'm going to add Cordova. I wanted to pick a rural location. I was born and raised in Cordova, so logistically, I know a lot of the people and the places and how things work there. So I'm very comfortable being in Cordova. Anyway, so that's the demonstration plan. So in conclusion, this plastic ocean waste is a growing problem, especially shore-based accumulation. There's an opportunity, lots of opportunities for innovation to tackle some of these problems, especially when we look at some of the technologies that are being developed, like drones. And then compensated collection is an opportunity for us potentially. And we're working right now on a mobile processing solution that could work for Alaska. So that's my story, and I'm sticking to it.